Okay, we are recording, and while we're waiting for PowerPoint to decide what it's going to do, it hasn't changed. Oh, it has changed. Let me go through these last few announcements. The question was, can I take the test? That's my question to you now. Do any of you want to take the test now before the review period? Okay. Then her question was, right after, can you take it? Absolutely. Anytime from now until Thursday afternoon. Okay? I would say even into the evening, Thursday evening. I'll be here till 8 o'clock, but please get started at it in plenty of time for you to finish before 8 o'clock Thursday evening. So don't get started any later than 6, okay? But anytime between now and Thursday evening at 8. I will not be on either campus on Friday, so don't say, can I take it on Friday? No, you can't. I won't be here. And grades are due Monday, usually by noon. So I've got to have them completed by Thursday afternoon, okay? Love to have them completed sooner, but by Thursday afternoon. All right. I have returned all your papers so far to you. I want to answer any questions. Has anyone still got anything outstanding? Like, I think all of you were here before. You've turned in all quizzes, all tests. You've gotten everything back, right? Does anyone not have everything back? Okay. So since you do have it, then I will try to answer any question you have on it. The trouble is there's a few people who have not finished everything, and so I can't really record on Screencast-O-Matic because then they would be able to see the answers. But I can answer conceptual questions on it, and then after class go over it with you when I'm not on Screencast-O-Matic. Okay? If not, ready to start the review. And y'all are in charge of this, remember? You asked me the questions. I'll try to work the issues. Let's see. Let's get the slideshow set from current slide. All right. Last time we started and answered several of the multiple choice. I don't remember that we did any of the short answer, but I'll do either of them. Does anyone need a copy of these questions? And you can, yes, you do? Okay. I may have to get it back if I don't have a spare copy, but that's the multiple choice question, multiple choice answers, and the short answer questions. And oh no. Okay. Turned around like that. Yeah. Okay. Does anyone else need a copy of either the multiple choice questions or the short answer questions? Okay. I do have another copy, so I'm ready to go. All right, any questions from any of these? Multiple choice or short answer? Y'all had all weekend to work on these and see what you were missing on. Any? Boy, you know them all. Wow, aren't you taking the test? Okay. All right. Yes?
Number 16.
16? Is that what you said? Yeah. Okay, on which? Short, multiple choice? Yeah. Okay. All right. So this is, I think it's called Comprehensive Review. Ooh, let me get my pen to black. Okay. Comprehensive Review. This is multiple choice, number 16. All right. It says divide. P squared. I lost it. Yeah, there it is. Plus 2p minus 32 divided by p plus 7. Plus 7. Okay, now they put these in parentheses. Probably is that correct to do so. Okay? I want you to tell me, because we've done this, what would be your approach? Synthetic division would be her approach. How do you do that? Say again? Okay. She may not should have chosen synthetic division. You put what? No, okay. Put -7 inside the box. Always change the sign of that. Okay. Josh Brown is here. If I can find you in the light here. You're blinding me. You're too bright. Okay, all right. So, -7 goes in the block. The opposite of this. Why could she use synthetic division? Here's a naked p, okay? Coefficient of 1, exponent 1. It's the only time you can use synthetic division. It has to be a binomial whose first term, the variable term, has a coefficient of 1, variable of 1, exponent of 1. Only time you can use synthetic division. Then you change the sign of that, okay? What goes next? Say again? Coefficients, and what are they? 1, 2, -32, isn't it? If I wrote it right. Yeah. Okay. Now, what I always do next is count to see how many I have. How many you got? 3. Is that the right number? Always one more than the degree of the polynomial. Otherwise, you probably had some missed terms, and then you'd have to put in zeros. But you have the right number, so you're fine. Next. Skip a line, draw a line. Yes, I knew you were going to say that. All right. And what? Bring down the 1. Say again. And what do you get? -7. -5. Positive what? 35. New. -32 plus 35. +3, okay. And why do I do that? It's a remainder, exactly. You block off the first, block off the last. What does this tell you? What is the answer? Say again? P -5 plus 3 over P plus 7. Got it. I don't hear well. Let's see if they have that answer somewhere here. What you think? Yeah, looks like a B to me. Don't know it. Okay, 15, is it? No, 16. Sure enough, it's a B. They got it right. Now, David's going to do long division. Y'all want to see that or not? Doesn't hurt to see it. Okay, because you would need to do long division if that had been a squared here or a coefficient of 2 or 3 or 15 or whatever. So let's do long division. Outside the house, you put P plus 7. Again, you make sure you're not missing any terms. Inside the house, you put the dividend, which is P squared plus 2P minus 32. And then what do you do? P into P squared goes how many times? 1P. Okay. And then you? P times P is? P squared is plus 7P. And now you do what? Subtract. And what would that give you? That would be 0 for the first one. Change signs and add. I like that. Okay, so we're going to change that to a minus and add. And what does that give you? -5P. And then what? Bring down a minus 32 and do what? And what does that give you? No, minus 5. The P's go out, yeah. Okay. right? Minus 5p.
Minus 5 times minus 7.
Right?
Minus 35.
Minus 35. Now what?
Change the sign.
Change signs and add. Exactly. These go out. And what are you left with? Remainder 3. So you could put plus 3 over p plus 7. Both ways give you the same answer. They better. Okay, that takes a little more, less room. And you might be a little less likely to pull a P in there when you shouldn't have had or something like that. So it's up to you, whichever you feel more comfortable with. Okay, I got to get Jackson here. Or he already got here, but I have to mark him here. Okay. And let's see. I can't recall. Have I returned everything to you? Quizzes and tests? Okay, all right. All right. Any others? We're doing the review sheets. We just did 16 on the multiple choice. Any questions on that? Does everybody see it? Does it answer the question of whoever asked it? Yeah, Frank. Got it? Yeah.
64.
Second?
64.
On multiple choice? Okay, yeah, that's right. That one doesn't have 64. Okay, this is way over on page somewhere back here. Looks like page 11, 64. Ha! Good question. Excellent question. This is something we didn't have a chance to do. Okay? We'll erase all that ink. This is number 64. Now, if you are following the book, I saw some of you had the books open. Excellent. This is a chapter on systems of equations. Is that 10? I don't remember the chapter number, but it's somewhere over there. We're only going to cover a couple sections in it. Here is one. 64. 3x over 2 minus y over 3. And Colton Boyd is here. Good deal. See in this bright light. I think that's you right there. Okay. Woo. Okay. Is equal to negative 18. Okay. 3x over 4 plus 2y over 9 is equal to negative 9. Okay. Now, what this is called is a system of equations. 2 equations, 2 unknowns. If you have one equation with 2 unknowns, the best you can do, especially if they're linear equations, that's all we're messing with now, then all you're going to get is a straight line. Any ordered pair on that straight line is going to give you a solution. However, if you have 2 equations with 2 unknowns, then you have a possibility one of 3 things are going to happen. You will find an exact solution, which I think we'll get here. You will find an infinite number of solutions. If these 2 wind up being the same line, then again you have infinite number. Or you'll wind up with absolutely no solutions. And that would be if these 2 lines are parallel. Okay? They never cross. That exact solution would be if these 2 lines are not parallel, but they cross somewhere. If they have an infinite number that's the same line, they're same line, same slope, they're parallel, however, they all fall in the same value. This one, I think, will give us a unique solution. How are we going to approach something like that? What seems messy about it? Say again?
The whole numbers.
Okay, you think the whole numbers are the messy part?
The whole numbers and also you don't have least common denominator.
Okay, yeah. We have fractions there. That's the messy part. So here's my take on how to deal with that. Let's get rid of the fractions. And you mentioned common denominators. That's how you do it for each of those equations. The first equation, what's the least common denominator? 6. So what are we going to do with that? Multiply each term on both sides of the equation by 6. Okay, and that gives us a new equation on top. And what would that be? 2 will go into 6. 3 times 3x is 9x, okay? And the next one, 3 will go into 6. 2 times y is minus 2y. Don't forget the sign. And 6 times minus 18 is, boo, big number. Second, no, it's not over anything. Negative 108. Very good. Okay, we're going to do the same type of thing to the second equation. What's the first question to ask? Denominator, what is it? 36, unfortunately. Big numbers again. 36 here, a 36 there, and a 36 here. Okay? What happens here? 4 will go into 36. 9 times 3x is 27x. Very good. Next place. 9 goes into 36. 4 times 2y is plus 8y. Okay? And lastly, we have, I think that's the 54, 27 and 5 are 32. And that's a negative. All right. Big numbers on the end, but don't let them scare you. We can deal with them. Sort of big numbers in the beginning, too. All right, here's what we do next. There's several ways you can approach this. They say do it by elimination, which is, to me, the only way to do this one. That's not the only way. The best way to do this. Here's what they mean by elimination. We look at both equations. You have at least 2 options here. What we want to do is eliminate one of those variables. Okay, that doesn't mean erase it. You have to do it legally. Now, how would you suggest that we go about eliminating the x? Remember, with equations, you can multiply the same thing by both sides of the equation. You have an equivalent equation. What could you do to the first equation to eliminate the x? Say again? Not by 9. By 3. Only I'd do a minus 3. Then you'd have a minus 27 here. You add those together, and guess what? You eliminated the x. But you have another option. How would be the best way to eliminate the y? Okay, multiply the top equation by 4. And then this becomes a minus 8y plus 8y, and that would eliminate. Your choice. Smaller number, 3, but bigger numbers here. I don't care which way you want to go. Your choice. This one you need to have a minus sign, that one a plus will do. Say again? The x with a negative 3. We'll do it because Jackson told us to. So multiply the whole equation. Let me do it this way. I think that would be a little more sense here. Let's multiply the entire equation by negative 3. So I'll go write it underneath. Negative 3 times 9x would be negative 27x. Negative 3 times negative 2y is plus 6y equal minus 3 times negative 108. $324, positive 324. Pretty amazing, huh? So don't worry about those big numbers. Look at what happened. Okay, now what do we do? You can always add equals to equals. I remember my high school algebra teacher, Algebra 1 teacher, Miss Virginia Dozier. Equals plus equals equal equals. You know, she would talk through her nose. It was really nasty. Okay, but what happens when you do that? You eliminate the x. And what do you get here? You get 14y. And what do you get here? 0. Can you solve that equation? Yes, we can. What will it be? Y. Oh, wait a minute. I thought we could. Y equals 0. You divide both sides by 14 because these are multiplied. That gives you y is equal to 0 divided by 14 is 0. Now what do we do? Yes, we go back to either equation you want to. And you could go to the original ones, but they still have the fractions in them. So I think I'd go to one of those two. Which one looks easier? The top one. And plug in y is equal to 0. That would give you 9x is equal to negative 108. And then what would we do? Divide by 9, and you get x is equal to, is that negative what? Negative 12. So our solution, our one and only solution, is going to be an ordered pair minus 12 comma 0. Now, being the cynic that I am, I like to go back this time to the original equations. Because guess what? Chris could have made an error there and got me all messed up, okay? So therefore, I want to go back to the original equation and plug it in, okay? And see if it works, okay? Trying to get this to hit, and it hit the wrong button. Okay. Now, if you plug a minus 12 in for x, you get 3 times the negative 12 over 2 minus 0 over 3. Is that equal to negative 18? Well, will 2 go into negative 12? How many times? Negative 6, and 3 times negative 6 is? Negative 18. I'll buy that one. Okay. I should have done this when I had the eraser up. I'm going to wipe out all these too. Go back to the original. Okay. And plug in. So, okay. Okay. All right, let's plug it in here. 3 times the negative 12 over 4 plus 2 times the 0 over 9. Is that equal to negative 9? Let's see. Will 4 go into negative 12? How many? Negative 3 times. Negative 3 times 3 is negative 9 plus 0 is sure enough equal to negative 9. Works. That solution works in both equations. We have solved it. The one and only equation that solves both equations. Solution that solves both equations. Now, what would it have looked like had it been an infinite number of solutions? Then when you tried to do your work here, that first thing we got to was over here, wasn't it? You might have gotten something like 12 is equal to 12, or 15 is equal to 15, or 0 is equal to 0. Something that's always true. Guess what? If it's always true, then you have infinite number of solutions. Okay? Now, on the other hand, if you'd have gotten 15 is equal to 3, or negative 5 is equal to 12, or 0 is equal to 5, guess what? That's never true. Then you have no solutions. But most of the time, you'll wind up, I think, with one and only one solution. Okay? 0 is perfectly fine. Okay. Does that answer your question, Karen? Yes. Okay, good deal. That was one of the tougher ones there you'll see, because it first had the fractions you had to get rid of, then you get it in a nice, reasonable linear form, but you had big numbers, still plow through one bite at a time, and then suddenly everything turns out pretty nice. Okay? And it did work. Good question. Any others?
60.
60? Ah, good question again. All of them are good questions, by the way. I didn't make them up, but they still are. Okay. So, 60. All it says is simplify. The fourth root of 625 divided by 256. Now, how would you approach a problem like that? we were in the chapter that we were touching on this. Not sure we got this far, but we could have. How would you proceed?
Square root of each one of them.
The square root of each one? That's not a bad way to go, because this is a fourth root. If you take a square root twice, you're going to get a fourth root. It won't work on all of them that way. If that had been a fifth root, the square root tells you nothing of any importance, okay? But in this case, you happen to hit on something right. Now, you probably knew that and was really clever on it, but if it's not working that way, here's what I call the sailor-proof method. You know, if you do what you can, I would do a prime factor. Well, there's a couple things you can do. If you remember our three rules we did talk about, and David was hitting on one of them. You see if there's any perfect roots of those inside the radicals, okay? Okay? These are big numbers. I don't see them right off the top. I know because I do see them, but I'm pretending I don't, okay? Secondly, we don't like denominators in a radical. We got one. And the next thing I was going to do is split this up and make it the fourth root, because this is legal in most states, of 625 divided by the fourth root of 256. Okay, that's still got a problem because now you have a radical in the denominator. You don't want denominators in your radical, but neither you want radicals in the denominator. Now here's what I suggest you do. I see Chris pulling out his calculator, probably going to cheat on me, but that's fine. You can use your calculators during the test. Perfectly legal. Here's what I suggest, though. Keep that fourth root, and let's do a prime factorization. What's the smallest prime number that'll go into 625? 25 is not prime, but it will go into it. 25 goes into 625 how many times? Do you know? Say again? 25 times. Look at him. That's why he pulled out his calculator. He did that in his head. Good for him. Okay, let's go on and do the denominator while we're doing. Okay, fourth root. What's the smallest prime number that'll go into 256? Say again, 16. And what will it go into? Say again. How many times will 16 go into 256? 16 times. Y'all are good, or else I don't know what's going on here. Okay, here's what I suggest you do now. Okay? Now, we're at a point we could have done something else, but I'm going to show you, proceed this way. Continue the prime factorization. 25 is not a prime number. What's the smallest prime number going to 25? 5 times what? And we'll do it on the next one too, won't it? 5 times 5, okay? And on the next one, smallest prime number will go into 16. Okay, that's not prime, but we'll live with it. 4 times 4 times 4 times 4. Now, guess what we got? We didn't get down to prime factorizations, but look what we got. We got the fourth root of 5 to the fourth divided by the fourth root of 4 to the fourth. And what do you notice can happen now? The roots undo the radicals, undo the powers. The 4s can, in a sense, cancel out. That's not the best way to say it. This is exactly 5 over 4, and that's your answer. Okay? Now, that was one way to get there. Okay? Justin's here, right? Can't see for the light here. I think I found the right place for you. Now, I may have a paper or two of yours, so don't leave until I give it to you. I can't remember, but I think I do. Okay. That's your answer. If you can get it, and what basically y'all wound up doing was doing what David suggested in the first place, kinda, is see if you can find a perfect power, the fourth power of any number that fits there. Oh, and by the way, we didn't check to see if they had that as an answer. They got 5/4 as D number, and we didn't do this on the other one either, did we? Number 60 got an answer. D, look at that. They got it right. And the one before that we did was 64. We said negative 12, 0, didn't we? Or did we do 0, negative 12? It's negative 12, 0, wasn't it? Yeah. And that was B, and 64, sure enough, was B. Good for them. Okay. Got it. Do you see how to do this? Okay.
Let's do one more with three. Let's do one with the odd number instead of 4.
Okay, find one.
62, 3.
62. Okay. All right. It's the cube root of negative 1,000. Okay. Now, what would you do on this one? Okay, no, square root doesn't do you a bit of good here, okay? But do a what? A cube root. Can you do that? Some of you have it on your calculators, you can do it. Fine. It's what?
10 times 10 times 10.
You got it. Only it's the cube root of a negative 10 times a negative 10 times a negative 10. If you did 10 times 10 times 10, you're going to get a positive 1,000. But if you do all three negatives, these all three comes out being, and that's the same number inside, which is the cube root of negative 10 cubed. Lose the root and the power, and you get negative 10. That's your answer. And again, y'all factored it and factored it well. You didn't do prime factorization, but you did what you needed to do. So that gave us a C answer. And let's see what they got for 62. My goodness, they got C2. Excellent. Okay. Good deal. Does that make sense? Does that answer your question there? Yes.
Can we do 45?
45. We hope we can. Okay. 45. Let's back flip it. All right. Whoops, flip another one. That's a graphing problem. Okay. Let me go to graph paper. This will be number 45. Now this is pretty limited graph paper, so let's see. It says graph this one. F of x is equal to x squared minus 2x plus 2. Okay? Now, my first question to you is, how would you proceed to do a graphing question? Okay, find some points. Do you call that a T-table, or is that what y'all call it? You may not. I've heard it called that in the past and other things. Find some points, okay? Now your points are, on the graph, x, y pairs, exactly. What is your x here? Pretty obvious. The x. Do you see a y up there? Okay, guess what the y is? F of x. Remember that about functions. F of x is equal to y. So that's going to be our y. So you can change that if you want to and say y is equal to x squared minus 2x plus 2. And then you find some points. What's the easiest x to do? 0. And if you put a 0 in for x, what y do you get? No. Let's plug it in. Y is equal to 0 squared minus 2 times 0 plus 2. 2. So when x is 0, you don't go right or left. And for y2, you go up 2. There you go. Just don't say yours. Okay. Give me another x. 1. Okay. And what do you get there? Y is equal to 1 squared minus 2 times 1 plus 2. What's 1 squared? 1 minus 2 plus 2. Guess what that's going to be? 1, because these add to 0. So when x is 1, y is 1. Whoa, that's not right, is it? No, it can't be. There's something wrong here. Yeah. Okay. I've got a problem here. Let me see. 1 squared minus... It sure looks right to me. But this is coming out. Oh, no, this is fine. It's fine. It's perfectly fine. I just hadn't gone far enough, okay? Give me another x. Negative 1. So here y is equal to negative 1 squared minus 2 times minus 1 plus 2. What does that give you? What's negative 1 squared? 1. What's minus 2 times minus 1? Plus 2 plus 2. What does that give you? 5. So negative 1 is up here at 5. 2, 3, 4, 5. Okay? Give me another x. Second? 2. Y is equal to 2 squared minus 2 times 2 plus 2. Boy, there's lots of 2's here. Okay? What does this give you? 4 minus 4 plus 2. What does that give you? 2. There you have it. Okay? Next. Negative 2. I was afraid he was going to say that. Y is equal to negative 2 squared minus 2 times negative 2 plus 2. What's negative 2 squared? 4. Yuck! Come back here. Okay. All right. Okay. I know I was trying to write a 4 and it messed up. 4 minus 2 times minus 2 is? Yeah? Positive 4 plus 2. 4 plus 4 plus 2 is? 10. Off scale. That's why I didn't want you to do that one. Okay? All right, let's do 3. Y is equal to? You tell me. 3 squared minus 2 times 3 plus 2. What would that be? 9 minus 6 plus 2. What's that going to be? 5. Very good. 3, 5. Right there. Okay? Guess what we got here? A nice shape that looks... Does anyone know what we call that shape? A parabola. Exactly. Parabola. Okay, what a parabola is something that's symmetric about a line of symmetry, and x equal 1 is that line of symmetry. Same thing on the right and the left of that. And by the way, a lot of things in nature, yes?
Is a parabola the one where, like, if you look at the x squared and it's positive, it opens?
Absolutely, she's got it. Any quadratic, which means the exponent of 2 is going to produce a parabola. If the coefficient of that square term is positive, that parabola is always going to open upward. That's why I got worried at first. I thought this was opening downward. I said, oh, that's not my vertex. We haven't gotten to it yet. So that's what was bugging me. Okay? And if that had been a negative here, then it would have opened downward. Okay? So they're always symmetric. Okay? Any of you ever shoot a basketball? Probably not, right? Yeah, of course you have. Guess what path a basketball follows? A parabola. Hit a baseball, hit a golf ball, throw anything. You know, things follow a parabolic thing. Any of you have headlights on your car? I hope so too. That mirror behind that is a parabolic mirror. Because if you place something on the focus here, that's what they call it, of a parabola, and send out light in all directions, then the beams are going to come out parallel. Okay? Any of you have a disc or have seen anyone with a disc at home, for satellite disc, dish, whatever you want to call it? That's a parabolic shape, and they have this thing sticking up here on the focus. It picks up the signal, and that whole thing from the satellite points toward the satellite, picks it up, goes right to the focus. That's how you get your signal. Okay? Lots of things in nature we use every day. Parabolic. The mirror behind the light bulb in a flashlight. Parabolic mirror. Okay? That's a parabola. Okay? And you're absolutely right. If the leading coefficient is positive, it opens upward. Leading coefficient downward, negative, it opens down. Very good. So any of these fit the bill here? So it looks like C to B. Let's see, number 45. C, good for them. Okay. Does that answer your question? Good question, by the way. Any others? Yes. 19. Okay. There we go. Let's go back to this and clear the screen. Clear the screen. Here we go. 19. Evaluate the polynomial function for the given value of the variable. It's number 19. Okay? Find P of -5 when such that P of x is equal to 3x cubed minus 4x squared plus 9. How do you reckon you're going to do that? What would be your first guess? What do we do with Glade? Plug it in, right, okay? So, wherever you see a -5 here, so you got P of -5. Over here you got P of x. So everywhere you see an x here, put a -5. So P of -5 will be just like we were doing before. 3 times -5 cubed minus 4 times -5 squared plus 9. Okay? Now, some of you may have to scratch your head a little bit and tell me what -5 cubed is. Say again? -125, absolutely. Okay? Now, what do you do next? So, you called it out to me before. I think it was Jackson. Rule of order of operation. Write down the -4 because you got to do the exponent first. What's -5 squared? 25 plus 9. Okay? What's 3 times a -125? 375. -375. And what's -4 times 25? -100 plus 9. Did you finish both of them? All right. All right. Okay. Now, we're still doing the review if you want to participate. We're still doing a review if you want to participate. Okay. All right. It's free. I mean, okay. All right. What does this give you? -475 plus 9. And what does that give you? -466. Oh, could that be an answer? Looks like B to me. Number 19, sure enough, is B. Good for them. You see how that works? If you have questions about this, don't just sit there. Ask me questions, okay? Anything magical or unknown or confusing about it? Plug it in, plug it in. Okay? That's what we mean by a function. P of x is plugging in whatever that x value is. F of x, plugging in whatever the x value is. That's what a function does. Next, any others? Number 4 on the written out part. Okay? So let's clear this page. Okay, this will be the final exam review, FER, and this will be short answer. Okay, and which one did you say? Number 4. All right. Number 4. Excellent question. Okay, number 4. Find the domain of f of x is equal to 2x plus 7 over x squared plus 5x plus 6. Okay. Now, what do we mean by domain? Anyone remember? We talked about this a little bit on Wednesday. Yes. All the values you can put in for the input variable. Okay? What is your input variable? Your x, exactly. Okay? Now, here's where we always start with. We'll assume it's all real numbers, unless we can find some we have to exclude. And that's where the question comes. What excludes an x from being an acceptable value? Right now, you only know 2 things that do. Okay? I'll tell you what they are. What is one thing you can never do in arithmetic? It features one of the first 4 basic operations you learned. You cannot divide by 0. Okay? And then there's one other thing that we've done more recently in the next 2 operations we learned. After you had addition, subtraction, multiplication, dividing, then we raised things to powers and took roots. Any of those have any restriction? You cannot take the square root of what? No, you can't of 0. A negative number, that's the second thing. You cannot divide by 0, you can't take the square root of a negative number. That's all you have to remember. Does this problem have any square roots in it? No, so you don't have to worry about that. Does it have a division in it? Yes, it does. So the only place that you're going to run into potential problems here is if that denominator can be 0. It can't be 0, right? So let's do that. Let's play with that. We said x squared plus 5x plus 6 cannot equal 0. You told me that, right? How could we find out what values of x would make that 0? What's your F word? Factor it. Okay? Only this time you're saying it's not equal to 0. Now, if that would factor, how would it factor? X times x, and what do you say? Plus 3 plus 2. You're getting good at this, you know? Okay. You agree with that? Multiply it out. Sure enough, that's what you get. So what does that tell you? X plus 3 cannot equal 0. Now, before when it was equal to, we said or. Now we say and. Okay? No, we said and before. This time we say or. I said it backwards. Sorry about that. No, it's and. That's and. We said or before. This time is and. X plus 2 cannot equal 0. Okay? So what does the first one give you? X cannot equal negative 3 and x cannot equal negative 2. All right, so the domain. There's two ways you can express that. One is in set notation. That would be your domain, I'm going to write it this way, of F, the way they gave it to us, is the set, that's what a set is, of all values x such that, and sometimes they'll actually write in, x is a real number, x is a member of the real number system, as long as x is not equal to -3 and x is not equal to -2. Okay? Now sometimes I'll leave out that x is a member of the real number system, but that's basically what you say. All the rest of the x's in the world, except you can't have -3 or -2. You have holes in it there. Every other x is fine. That's the domain of that function. Now, if you wrote this in interval notation, which the book loves, but the and since you're doing this here, I'll be able to understand it. Interval notation. Okay, again, imagine you're at all real numbers. Where do you start all real numbers? Huh? Negative infinity. Okay? You start with negative infinity, and I'm only doing this because if you move on to Math 112, you'll see this again. Up to -3. But you can't have -3 in there. And then they do a union and start again at -3 and go to -2. But you can't have -2 in there. Then you union that again with -2, and this time you go all the way to positive infinity. That's right. Okay? That would be another way to express that. I really don't like that as well, but they do that in the Math 112 book and even in this book. I like this. It says it really clearly. Set of all x's as long as x isn't -3 and not -2. That says it all. If you just write this down, I'll understand that on short answer. If you're trying to match it up multiple choice, then you have to get it in one of the forms that they give. So that's why I'm showing you all the different forms so you can see, oh, okay, that's what it means. Now, they don't have a key for this, but that is the answer. Any real number in the world, as long as it's not -3 or -2. That's your domain. All the rest of those will work. Every one of them, except -3 and -2. Okay? See, the numerator didn't matter who. Didn't care what that numerator was. Yeah. Oh, that's my phone. I'm sorry. Okay. Something's got my number and it calls. Hollywood, Florida. I don't even know anyone in Hollywood, Florida. Okay. Okay.
What is that? What is written after the X in the line?
Okay. This means the set of all x's such that, that's what the vertical line means, this is x is the element of the real number system. Okay, meaning it's a real number, and as long as x is not equal to -3 and not equal to -2. Since this is short answer, I would have blocked that in. I forgot. I was thinking we were doing multiple choice, then I was giving you all these so you can find it. Do this, you get that answer, I'll get it. Say, yes, that's correct. Okay, on short answer. Multiple choice is graded by a machine, not by me. You get that right, you got it. I saw another hand up. Was it Kara? No, okay. Yes. 47. Any questions on this before we leave it? Yes.
I'm sorry, I was just going to say which 47.
It's probably on the multiple choice because I don't think there's but 36 on the other one. 47, you said? 47. 47. There it is on page 9. All right, good question. Okay. Okay. Here's 47. This is back on the multiple choice part. It says, is the following correspondence a function? Sometimes they'll call that relation. Is this relation a function? And it says 1 maps onto -15, -6 maps onto 15, and -16 maps onto -7. Okay? The question is that a function? Anyone tell me?
What is that? I don't even know what that means.
Okay, that means if you have this for your x, that's your y. If you have this for your x, that's your y. If you have this for your x, that's your y. This is the input, that's the output. This is what you put in the sausage grinder, that's what comes out. Okay? Now, for something to be a function, this is after the fact that f of x equal y, that's the most important. After that, the next most important thing to know about a function is, remember, if you're standing in line at the bookstore, okay? If the guy ahead of you pays 49 cents for that candy bar, and then you have the same kind of candy bar, you put it down there and they charge you 59 cents, you're not a happy camper, are you? Because you think you ought to get the same price he does. Well, if you feed in an x and get out a y, any other times you feed in that same x, you better get the same y out. Well, does this fit the bill? These are three different x's. Yeah, you can get three different y's out. That's no problem. If this would have been a -1 here, gave you -7, not a function. Because, oh, I'm sorry, a positive one there. All right, let's do it this way. If that had been the problem, -6 gave you 15 here, -6 gave you a -7 there. Not a function. It is a relation, it is a correspondence, but it's not a function. Remember the vertical line test? We had one like that last time. Any vertical line, if it cuts it more than once, not a function. That would have been. For this one, have only one input, one output, you got it. It's a function. So this should be a yes. 47, B is a yes, yes. And besides, that was a 50-50 chance of getting that one right. That's what a function is. A function, for any input, you can only have one output. You can't feed in a -6.
What would make that no?
No. That would have made it no. Feed in a -6 here, you get a 15. Feed in the -6 here, you get a -7. Can't happen. Anything you feed in, you got to have the same thing out.
So you're saying if that bottom one was 6, then the next one should get 15 too?
Yeah, it better be a 15 to make it a function. If it's a -7, that's not a function. You can't have two people paying the different things for the same price.
Okay, I get what you're saying.
Yeah. Okay?
So like, there's three sets of functions, but so like say the left side is
Okay.
X, right? And then this is Y.
Right.
If you have the same X,
Yes, and that's a good way to look at it.
side too. Is that
If you have the same x showing up here, you better have the same y. If you don't have the same x, yeah, it's a function.
It's -6 already. We had the last one was -6. It needs to be 15. So it can't be -7. So he said, why would you
Yeah.
59 so you can't 40?
Okay.
15 and that is 6.7.
Okay, I was giving you the reason for it. That's really the best way to look at it. Say, look at this. If you see the x's repeat themselves anywhere, then those y's for those x's had better repeat exactly. If they don't, not a function. Okay, what time is it? It's what? Okay, but we go till 8:50 this morning. I mean, you can leave anytime you want to. But you see, final exams go an hour and 50 minutes, not an hour and 15. So I'll keep going until, yeah. There's no classes today, so you don't have another class. You may have another exam, but it won't start until 10. So you do have a class? Are you in a mini-term? Oh, mini-terms do have. Sorry about that. That's the problem. One of the other problems with mini-terms. They mess up your final exam schedule. Yeah.
Oh, I got that other class after this. Can I go ahead and start on the test? Because it'll take me like a couple hours.
Okay. I thought you had a test now. I mean, a class now.
I do, but we probably won't have the test until 10, so I can have time to be able to like work on it. If so.
Okay. Well, yeah. Okay. Okay. Yeah. You can start on the test anytime you want to, but you see, that's the thing. If they're not a mini-term class, it's not starting until 10. I mean, your test. You're not having a 9:30 class this morning.
Okay.
Do you know that?
Can I get it and take it like
You want
up
to
my
start it
test
now?
just to start it?
Okay. Well, why don't you go next door? Okay.
So I want you to.
You do too.
So say Wednesday when we come in here and we want to start, or can we start the test? Will we be taking it in this class or will it be in a different room?
Okay. That's a very good question. Let me answer that one. Okay. I meant to answer it in the very beginning, okay? I just forgot to do it. Where am I going to be for the rest of this week? Well, if I'm giving a test, I'll be in this room. Okay? If people come in to do a makeup or come in to do, then more than likely I'll pick some classroom between my office and here. I'll start near my office and work my way this way. So just look for any of the classrooms up until here. If I'm in here giving a test, you can come take a test. None of my classes, this class comes the closest to filling the room. So yeah, you'll be fine. But if I'm not, try my office next, 265, and then try all the classrooms coming up. If you don't see me anywhere there, I may be at lunch, I may be in the restroom, I may be in the registrar's office, maybe somewhere else. Just wait a few minutes, I'll show up, okay? Anytime between. So, yeah, is that answer?
Wednesday morning, like during this.
Wednesday morning, if I'm not in this room, come get me. I'm in my office. We'll come up here, or we'll go wherever you want to go. Well, within limits. Okay. All right. You want to get started on yours? And Brandy wanted to do hers too? Okay. I just have a few made off because I wasn't anticipating that many people wanting to do it this morning. Let me find them. Okay. Here is the multiple choice answer sheet. Here's the multiple choice question. I got to go get some more of these. Okay. Now on this, do you have a number 2 pencil? You have to use a number 2 pencil. Put your name here, and that's really all you have to put. But be sure you put your name. Okay. There are 30 questions, and they're printed front and back, so don't forget to look on the back side. And you answer the questions A, B, C, D. I think that's all the choices here. Be sure you answer with a number 2 pencil marked completely. Don't put X's or circles or something like that. It's not going to read it. Don't answer more than once. He'll give you'll get it wrong. So, and then when you finish that, if you finish it before your next one, you can start on the other part. Okay. And I think next door is. I don't know if it's open from the outside. I know you can get that from here. Let me run and get a scan time for.
That's what I'm talking about. All this stuff is going on.
That's what like he explained one time, but that's okay. But I'm just saying it's not gonna like online or something. It's not gonna speak with you on our own. It's like one time.
I just think that screens catch my light on. But I'm just saying, let me say anything. So.
You can use your phone. Use it for
We had a meeting.
She said how, she said how, she said how was it? She came she took a detail, I mean, she said, I've never did this conversation. Well. So she don't know how to do it, I should probably.
Yeah.
Here are the questions, and we'll need to go next to them. You can use calculator, scratch paper. Well, actually, use this for scratch if you need scratch paper. Be sure you turn that back in. I can't. You know, this is 5 foot down. I have to roll it. Yes. Yeah. Yes, I do.
If I start on it today, I can come back tomorrow.
Okay, I'd like you to start this portion. If you start this portion, finish this portion. You can come back and do the second portion later, yeah. It'd be good to go and finish this portion. Yeah. Okay. All right.
Oh, yeah, tomorrow, what time are you free?
Pardon me?
What time are you free tomorrow?
Okay, I'm giving an exam 8 to 9:50. Just like this one, but there's plenty of room so you can come in and take it then. And then after that, I have a class, it's a mini-term class, 3:15 until 7:45. So we'll probably be through before 7:45. So
If I come within the time, I can still come though.
you could come 7:45 in the morning up till 3:15, and then later in the day, yeah, 3:45, 3:15. The class won't last till 7:45 because we've just got one lab and then someone may elect to take a test. But it's not going to be that long. But it'll probably go 2 or 3 hours. Then after some time, then I'll be free and eat. I just get paid by time. What's that? Okay, Wednesday, 7:45 until 4:35, something like that. Be perfectly fine.
In one of these classrooms.
I'll either be in this room, in my office, or some room in between.
Can, do like the test after I ask you to go over one problem? I'm not sure about it all.
Okay. Yeah. Well, I forgot to turn off that. It's been recording what y'all were saying. Okay. Okay. All right. What was your question?
Number 25.
25 on multiple choice? Okay. 25 on multiple choice. Okay. And I will be listening too. No, I'm just kidding. I'll never listen to those. Okay, 25. Okay, find all numbers for which the rational expression is undefined. This is number 25, multiple choice. Number 25. X squared plus x plus 84 divided by 9x minus 45. Okay? It says, find all the numbers for which that rational expression is undefined. Again, I ask you what 2 conditions would make something undefined. There's only 2 that you've had. can't you do, ever? Divide by 0 or take the square root of a negative number. Does this have any square roots in it? No. So you don't have to worry about that part. Is there a division in it? Yes. So what can you not divide by? 0. So your denominator here, 9x minus 45, cannot equal 0. How do you proceed? Solve for x. How do you proceed? Add 45 to both sides. That gives you 9x cannot equal 45. And then what do you do? Say again? Divide by 9. What did someone else said something? Yeah, I'm sorry. I wish I could make it harder, but I haven't figured out a way to do it. Okay. Yeah. Divide by 9, and what does that give you? X cannot equal 5. That's it, folks. X cannot equal 5. It says find all the numbers for which the rational number is undefined. X equal 5. That's D.
Well, what about 26? That was one more.
Okay, well, let's make sure they got it right. D, yeah, 25 was D. Number 26, okay. She's eating them up now, okay. Number 26. Same rules. X cubed minus x squared plus x plus 11 divided by x squared plus 24x plus 143. Okay. Now, it says find all numbers for which that rational expression is undefined. And again, I ask you what two conditions make rational expressions undefined. In fact, technically, in a rational expression, you can't even have a square root. You can in a function, but in a rational expression is a ratio of two polynomials. So guess what? Those square roots are out of the picture here, because number one, those are both polynomials. There aren't any square roots in them. So what would make that undefined? Yes, the 0 in the denominator. So basically what you do is say the denominator, which is x squared plus 24x plus 143, is not equal to 0. Now what would you do from here? Say again? Factor it. Very good. Okay, can any of you good enough that you can factor that right off the top? I'm not. Okay? If I were going to factor that, I would use a technique. But if you can do it, tell me how to do it. I would use the AC method. Remember that? Okay, you may have other methods. Some of you came up with some others that work. But I like the AC. I don't like it, but I use it when I have to. Your A here is 1, and the C is 143. And A times C would be 143. So AC equal 143. Now what we need to come up with are two numbers that add to be 143, no, multiply to be 143, but add to be 24. So what are the possible factors of 143? I'll do the easy one. And guess what? Everything's positive, so both of them are positive. 1 and 143. I know those multiply to be 143, but when you add them, you get 144. Not 24. Not work. Okay, guess what? 2 won't go into that, will it? So don't worry about 2. Will 3 go into that? No, 3 won't. Will 4 go into that? No. Will 5 go into that? No. Will 6 go into that? No. Will 7 go into that? No. Will 8 go into that? No. Will 9 go into that? No. Okay. Will 10 go into that? Will 11 go into that? You said it too soon.
Yes.
11 will go into it. How many times? 13. What does that add to? 24. Ding, 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 ding. Don't go any further. We found them. This will be x plus 11 times x plus 13. Sure enough, that works. So what would that tell you? X plus 11 cannot equal 0, and x plus 13 cannot equal 0. What does the first one give you? X what? X cannot equal negative 11, and x cannot equal negative 13. Those are the two numbers, the only two numbers for which that rational expression is undefined. Negative 11, negative 13, that looks like number A. So let's see, 26, sure enough, is A. Yes.
So on a scale of 1 to 10, what would you rate our final exam in difficulty? 10 being the most difficult?
I don't know. To me, it really doesn't seem like it's that difficult at all. But based on past experience, most students don't do as well on the final as they've done up to that point. Okay?
I have a question.
But I've had some students who have come in and just done so-so during the term and done really well on the final. So
Okay. I like calculated it up without my research paper in and with like my 2 test grade and 2 quiz
Cut it
grades.
off. Cut it off.
all right, we must be getting into some juicy stuff now. Okay, just a second. Let me. Oh wait, I was on the right page. Okay, you can't remember what?
How to change it, just slow.
Oh, okay, great. Find an equation of a line having the specified slope and containing the indicated point. Write your answer in slope-intercept form. Okay, number 28 is the the slope is negative 6. Okay, the point is 2, negative 3. Very good. Okay, now we want to find an equation of a line having the specified slope and containing the indicated point. Write your answer in slope-intercept form. Now, probably a good thing to do initially is to identify what is slope-intercept form. Can you tell me? Y is equal to mx plus b. Where m is the slope, guess what? We know that. B is the y-intercept. That's the only thing we need to find to answer this question, right? So, why don't we do what we can? Y is equal to negative 6x plus b. Now that's going to be true for every point on that line, including that one, right? So what we do is plug in those x, y values. What's your y value up there? Negative 3 is equal to negative 6 times what's the x value? 2 plus b. That we don't know what b is. But you know what? I think we can get it from here. This is minus 3 is equal to negative 12 plus b. And then what do we do? We want to find out what b is. Add 12 to both sides. And what does that give you? 9 is equal to b. So now we can go back to our slope-intercept form and go here and plug in that b. Y is equal to minus 6x plus 9. Okay? Now, I'm a cynic. I thought Aaron was telling me something wrong. So I'm going to check him and make sure. If I plug in a 2 here, what do you get? So I get negative 12 plus 9. Negative 3. Look at that. That's my y. Yes, that works. Does that make sense? Yeah. Okay. Answer the question? Yeah. All right. Good deal. See how we did it. Good. All right. Any others? 31, also on the multiple choice. Excellent question there, by the way. Both of these are, okay? Because we hadn't gotten to either one of those. We almost got to 31, but not quite far enough. So here's 31. Find the following, assume that the letters can represent any real number. Not very good instructions, I don't think. Okay. Anyway, we're doing the square root of 500, k to the 6th, q to the 8th. And that, by the way, is a square root. When they don't put an index on it, you understand it's to be 2. Everything else in math, if you don't see a number, you think it's a 1. With a radical, if you don't see a number, you understand that to be a 2. Okay. Now, how are we going to find the square root of that? Say again? Okay, that's certainly one way to go. So let's do the prime factorization of 500. What's the smallest prime number will go into 500? 2. 2 times what? 250. What's the smallest prime number will go into 250? 2 again. Will go into 250 how many times? 125. What's the smallest prime number will go into 125? 5. How many times will it go? 25 times. What's the smallest prime number will go into 25? 5 again. And how many times will it go? 5, and that's the prime number. So we've done the prime factorization there. Now, if you wanted to, we can do it with the next ones too. Okay? K to the 6th is k times k times k times k times k times k. I wouldn't do that if that had been k to the 106, but 6 I can write. Okay? And we can do it for q. Q times q times q times q times q times q times q. 1, 2, 3, 4, 5, 6, 7 times q. Okay, I don't like doing it, but it's okay. All right. Now, since this is a square root, I'm going to pick out every pair of factors I see. Okay? There's a pair, so that's going to be a 2 on the outside. There's a pair. That's going to be a 5 on the outside. There's a pair. That's going to be a k on the outside. There's another pair. That's going to be a k on the outside. There's another pair. That's going to be a k on the outside. There's another pair. It's going to be a q on the outside. There's a pair. It's going to be a q on the outside. There's a pair. It's going to be a q on the outside. And there's a pair. It's going to be a q on the outside. So that's all what's on the outside. What's left? Inside. 5. Okay? Now let's simplify this a little bit. 2 times 5 is 10. And k times k times k is cubed times q to the 4th times the square root of 5. There's our answer. Let's see if they got it. 10k cubed, q 4th, 10k cubed, q 4th, square root of 5. It looks like D. 31D. What did they? Oh boy, they got it too. Good for them. Now, do you want me to show you a slightly easier way? Remember what I said before, if you can see a perfect square in there, pull it out. When I look at 500, I think of that as 5 times 100. 100 is a perfect square of 10. Pull the 10 out, leave the 5 in. So there you got that part. Now, wish everybody else was here. I would give them all this in. They can listen to it on Screencast-O-Matic if they bother to. Here's the thing I like to do with exponents. Okay? And it's true for numbers too, but especially for variables. Another way you could have written this thing was, we've already dealt with the square root of 100 is 10, and you got square root of 5. I've already dealt with that part. I'm going to deal with the second part of it. that's k to the 6th, q to the 8th, the square root of that. Well, another way you can write the square root is to make the power 1/2. That means the same thing as the square root. The exponents up here, that was all to the first power, and the index is there. Square root, that would be that. Well, then remember the rules for rules for raising a power to a power. You multiply the powers. So the number part is still 10 root 5. And then what we have here is 6 times 1/2 is k cubed, and 8 times 1/2 is q to the 4th. So I would rewrite that as 10k cubed, q 4th. If it would have been an odd, then you take out the evens, separate the evens like it. If that would have been to the 7th here, I'd have done a k6 times k. And the k, square root of k, would have stayed in there with 5. That would have been left. Just like it would have here. If you had some of these, you'd have one that wasn't covered. So dividing by 2, since this is a square root, the problem here is a square root. On the exponents, just divide those by 2. If it's odd, go down to the next smallest even, okay? Divide by 2 and leave the 1 in the radical. Yeah. Now, if that was a cube root here, then the 4 would have stayed there. This would have been a 5 on the outside. Then you would have had 1k, 2k. But you see, 6 divided by 3 is 2, so that would be k squared. Here you would have had 1, 2, with 2 left over. So it would be q squared times the square root of q squared times the cube root of q squared. Okay. Q squared on the outside. But then that would have been 8 divided by 3 would have been 2, so q squared on the outside with a remainder of 2, and that would have been inside. Yeah. So that's another way to do it. This works. This is sort of sailor proof, foolproof, It always works. You can shorten it, though, if you remember those other little tricks. But you don't have to. This always works. All right. Then we got the answers they got, right? Yeah, we did. We checked it. Okay. Any others? What was the question again?
Undefined line or slope, is that vertical?
Oh, no, undefined slope is vertical.
Okay.
Horizontal slope is zero slope. Yeah. Neither increasing or decreasing, neither positive or negative, it's 0.
Okay.
Vertical is undefined, right?
How would you do number 36?
36.
On the multiple choice.
Multiple choice. All right, good question. Okay, let's go back to this one. Clear the screen. Okay. And that was the question he was talking about. Here they've actually drawn it for you. Find the slope of the line, and the first one is 4, 3, so you go right 4 and up 3. Okay? And you also go right 4 and go down 3. Now, number one, if this were asking, that would not be a function because you have the same input for 2 different outputs. So they're not asking that. They said, find the slope of that line. Well, here's the line that goes through those 2 points. It's a vertical slope. How would you find the slope? Well, what's the slope formula? This is number 36, by the way, multiple choice part. And that would be m is equal to, anyone remember it? y2, 2 minus y1 over x2 minus x1. It doesn't matter which one you use to be y2, which one you want to be y2. So again, the second one? So that would be a negative 3 minus 3 over 4 minus 4, right? Well, that would be negative 6 over 0. And when you see 0 in the denominator, undefined. Find the slope of that line. As you see a 0 in the denominator, undefined. That should be A. Number 36 is A. Good for them. Yeah, vertical slope is undefined. Divided by 0 is undefined. Yes, same thing. But there's your slope formula just in case you need it on some other problem. Any others? 34. Okay. Let's go back to the next page. Okay. I'll be here till around 4:35-ish today, and I'll be here 7:45 to 8 o'clock tomorrow, and about 7:45 to 4-ish or 5-ish on Wednesday, and 7:45 to 8 o'clock again on Thursday. Okay. So the question is number 34. Find the leading term and the leading coefficient. Here is the problem. Minus 16x cubed minus 11y squared plus 11xy squared minus 12x squared y plus 15x to the fourth. Now, what do we mean by leading term? Exponent, yeah, absolutely. And what's the exponent of this one? 3. 2. These you add together, what's that? 3. 4. That wins. So the leading term is 15x to the fourth. Okay? Okay, if I could write. What's the leading coefficient then? 15. It's whatever the coefficient for that leading term. Let's see if they got it right. It looks like B to me. And there says B. Good for them. Does that answer your question? Good. Any others? Say again? 40. Okay. Next page, I'm guessing. Yeah. Ah, good question. All these are good questions. Find the x-intercepts. Alpha of x is equal to 4x times, I can't write, plus x times x minus 7. Said find the x-intercept. What's true about the x-intercept? Say again? Okay, what's true about an x-intercept? What is an x-intercept anyway?
Crosses the X.
Ah, it crosses the x-axis. In other words, the x-axis intercepts that ball. It's a Nick Saban. Intercepts that ball. Where's the belt then? Remember? Okay, good. Okay, so intersect. So it's going to be, what's true about every point on that line? Every point. One of its coordinates is always the same.
0.
What is 0?
Y.
The y is 0. Okay. On this thing, what's your y?
FX.
Alpha of x. Exactly. You remember that. Okay. So all we do is set this equal to 0. Is equal to, now I've got to multiply through. That's going to be 4x plus, help me do that. Yeah, I got to multiply x squared minus 7x. Very good. Well, I want to rearrange that order a little bit. That's going to be x squared minus 7. No. Minus 3x, isn't it? The wrong button here. Okay. Okay. Help me do this. Okay. There's the x squared and what the other two?
Plus 4x.
Yeah.
Or be minus 3x.
Minus 3x. Very good. Okay, now what would you do with that?
Oh, no. What if you subtract?
Those are not like terms. They're at different powers. Same variable, but different powers. That's an equation. Trying to solve it. Factor it. Very good. I was going to ask, okay, how does this factor? X times x minus 3. Okay, and that's equal to 0. What? Either. Let's go make that true then. Two things multiplied together equals 0. Either what? You may have said it, I can't hear well. Equals 0, that means one or the other has to be 0. So what's the first one?
X minus 3.
Okay, either x minus 3 is equal to 0, or x equals 0. What does the first one produce?
X equals 3.
X equals 3, or x equals 0. There's your two x-intercepts, except x-intercepts are points. So the first one of those would be 0, 0, and the second one would be 3, 0, because the y is always 0, you told me. So those are your two x-intercepts, right? Let's see what they got. They said either 0, 0 or 3, 0. Looks like they got A. Sure enough, A. Excellent. Did you finish the A part?
I didn't finish it, but I got my other class. I was just going on. I got
Okay.
10 of them.
Okay. Okay. Now, next.
How would you find 39? The y intercept. What function?
Okay, on that one, how do you do y-intercept?
Yeah, 39.
Oh, 39, okay, yeah. Find the x and y-intercepts. Okay, let's clear this out and do 39. Okay. Find the x and y-intercepts. If no x-intercepts, state so. And here's what we got. Alpha of x is equal to x squared plus 8x plus 6. Okay? Which you want to go for first? Go for the y. What's going to be true about a y-intercept? Yes, x coordinate's going to be 0. So in other words, for the y-intercept, you do alpha of 0. And what would that be? 0 plus is 0 plus 6. So what does that add to? 6. So your y-intercept is 0, 6. Okay? Second?
0, 16.
Why 16? Oh, I'm sorry. I wrote the problem down wrong. Okay, 16. Sorry. I wrote down 6. Okay? Now, you did the y-intercept. Easy one, lazy thing you. Okay, how do we do the x-intercept? Yes, that's the y, which is alpha of x equals 0. So the x-intercept is set y equals 0, alpha x equals 0. That's equal to x squared plus 8x plus 16. Okay? Where would you go from there? Factor it. Will that factor? How? x plus 4 times x plus 4. Let's just check it and make sure. Yeah, x squared plus 4x is plus 8x plus 16. Yeah, I'll buy that. I'm going to put my 0 over here. It doesn't matter. Next.
So x plus 4 equals 0, and x plus 4 equals 0.
Okay, either one of those. And what does the first one give you? X equals -4. Second one gives you? All right, we have a double root, they call it. Okay, so there's really only one number. Your x-intercept is -4, 0. Okay, let's see what they got. Yes, sir. Is that it for the term then? All right, have you done the student course evaluation? All right, good. Thank you so much. I'll see you next term. All right, looking forward to it. All right, let's see if they got any of those answers there anywhere. They got -4, 0, 0, 16. Looks like C is what they got. And what do we get for 39? C, good. Okay. Any others? Does that make sense?
Yeah.
See how it works. Okay. And by the way, y-intercepts, where x is 0, there it is. That 0, that 0, that 0. Y equals 16, x equals 0, 0, 16. So easy to do that way. Yeah.
58.
58? Okay. It's going to be over a few pages. Bottom of page 10. Okay, let me clear out some space here. Simplify by removing a factor of 1. Another way they could do is just simplify the complex fraction. 1 over a plus 1 over 1 over a minus 1. Okay. Now, what's messy with that?
Fraction.
Yeah, you got denominators in a denominator, right? Fractions within a denominator. So, how are we going to clear those out? Find the least common denominator of all your denominators, numerator and denominator. And what is it? 8. It's the only denominator you got. So what do you think we might do with it? Multiply numerator and denominator. In fact, every term in the numerator and denominator by a. Multiply there, multiply there, multiply there, and multiply there. Now, what you're doing, you're multiplying numerator and denominator by a over a. That's your factor of 1. Okay? So, what's the first term in your numerator? The a's go out. That leaves you just 1 plus a, right? What does your denominator become? 1 minus a. You've done it. That's it. I'm sorry, I wish I could make it harder, but haven't figured out a way to do it. Okay? Looks like number B, 58, is on the next page. And sure enough, it's B. Any others? 56. Move up to very good. Rewrite without rational exponents and simplify as possible. Wish the others were here, but hopefully they'll listen. Okay, 56. 16 to the 7/4. Okay? It says rewrite without rational exponents and simplify if possible. Okay? Now remember what I told you the fractional exponents mean? The numerator is the power, the denominator is the index of the radical. So how would you rewrite this? The fourth root of 16 to the 7th power. Now, you could put the 7 inside, or you could leave it on the outside. I'm going to choose to put it on the outside. Well, not second, 7th, okay. That's a 7. You could put it either place, but most of the time, it's going to be easier. Do it last, okay? Keep the number as small as possible. That would be 2 to the 7th power. And if you had to multiply that out, that would be 2 times 2 times 2 times. Okay, let's do it this way. 2 times 2 is?
4
Times 2 is? 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 128. That's it. Okay? 2 to the 7th, which is 128. Now, what answer do they give here? Oh, they do 128. D, 56. It's on the next page. 56. D, look at that. They got it right again. Good for them. 63. Okay. Good deal. Solved by graphing. Label the axes and show where the solution is located on the graph. What I'm going to do is clear this out of the way. We'll do it here. The value V in hundreds of dollars is one's computer is approximated by V is equal to negative 1/2 T plus 9. This is in thousands of dollars, where T is the number of years since he bought the computer. Graph the equation and use the graph to estimate the value of the computer 4 years after it was purchased.
Okay, so I got up there and listen to this. Blackboard has crashed.
Really?
And unenrolled classes and everything, because I have CIS.
Uh-huh.
And so we can't do anything today.
You want to get back to it, huh?
Yeah.
Okay.
So I don't have my next one till 11.
What do I do with it? Here it is. Someone else came in and put something on top of it. Okay. So there you have it. Okay, you can go next door. What a fun thing to happen. Blackboard crashed during finals week. I love Blackboard. It's such a stable program. Yuck. Okay. Now, we're only using the first quadrant here. Okay? And it said where T is the number of years and V is the value in hundreds of dollars. Okay? Now, obviously I only got 1, 2, 3, 4, 5, 6, 7. I can't put 9 on it. So let's do 2. That'll be 2, 4, 6, 8, and 10. This will be hundreds of dollars. Okay, hundreds of dollars. Okay? Now, we're going at least 4 years. We can do that. Okay. 1, 2, 3, 4. This is V in hundreds of dollars. 5, 6, 7. This is a T in years. Okay? Years since he bought the computer. Okay. Now, doing graph, where would you begin?
This would be the same as like Y equals MX plus B, right?
Yeah, it is.
So
9 is going to be your y-intercept. That's a good way to start. And since 9 is halfway between 8 and 10, I'm going to put it right there. It may be hard to see, but there's your y-intercept. Okay? And then you do what?
you go down 1.
For every 2 you go to the right. Now remember, 1 on your y scale is half a block. Okay? But to the right is a full block. So this is going to be a little weird looking. So you go down 1, 2 to the right. Down another 1, 2 to the right. Down another, yeah. Down another 1, 2 to the right. and down another 1 and 2 to the right. I can't get that one in there, but here's what it would look like. Yeah. Something like that. Okay? And when that would be your graph, and then what would be the value of the computer from the graph, estimate the value of the computer after it's 4 years old. What would this be? Say again? $700. Okay. Okay. Let's see. Oh, they didn't draw the graph, so we just have to do. Did you get for number 63D $700? 63D, yes, $700. Now the other thing you could have done is, frankly, what I would have done is plug in 4 minus 1/2 of 4 plus 9. Now that minus 1/2 of 4 is, say again, negative 1/2 of 4. Yeah. Negative 2 plus 9 is 7. And this is in hundreds of dollars, so that'd be $700. How much was his computer when he bought it? Didn't say, did it? Well, guess when he bought it? How many years has he owned it?
Should be 900.
$900. Yeah, that would be your Y intercept. That's what it was at the beginning. Okay, now you might say, "Oh, what a dumb math problem! They just make up all this stuff to confuse us and stuff, right?" One of these days, you're going to be making enough money to do income tax, unless you're a president. No, I didn't say that. Okay, now. And when you do, and you own your own business, and you have equipment that you buy, you use depreciation to take advantage of the tax thing. My brothers and I as in parentheses, run the farm in Georgia that my brothers run it, since both of my parents have died, and we get a little bit of farm income or loss every year. And basically, when we buy a new piece of equipment, we can put it and set it on a depreciation schedule. That's exactly what this is. And we depreciate that piece of equipment on out. This would depreciate until about, 18 years out. Finally, that would go to 0. If you bought the computer for your business and are using it, you can depreciate using this schedule. Then every year you get to take $50 off. Okay. I think that's what it is, because it's minus $100 every 2 years, so it's minus $50 a year. So you depreciate it away.
Is that saying over time it'll?
What's that again?
Is that saying over time it'll wear out, or just?
Well, yeah, right. And let's say it died then before 18 years was over, then you could it died, so you can count that as a loss and pull all the rest of the value. But you can't ever subtract more value out than what you put in. Yeah. This is called the depreciation schedule. Generally, they tell you how many years you can do. They don't give you the formula like that. They'll say you can depreciate this piece over 5 years. This example on the farm. We purchased a new bull last year. We have beef cattle, and the bull can be depreciated. I can't remember. I think it was at a 5-year rate. But if we had bought a new tractor, which we couldn't afford, but if we had, probably depreciate over that over a 30-year rate, depending on the value of the object. So you you come up with your own formula, and then you depreciate that every year. Okay. Any others before we go? 78? Okay, if you need to go, you can go. I didn't say you had to wait, but 78. That looks like a page 13. Lucky 13, all right. 78. Solve this. Okay, I think we'll go to the other page. I'll clear this out. 78. Solve this. $38m squared plus 60m plus 21 equals 0. Now, where would you begin a problem like that? Yeah, I'm going to have to factor if possible. And I always look for greatest common factors. Well, looking at those three, 2 will go in the first or the second, but not the third. 3 will go in the third, but not the first. It would the second, but not the first. 4 won't go, 5 won't go, 6 won't go, 7 will go into the third, it won't in the first or second. There aren't any common factors. Boo hiss. Okay? Now, next thing might be trial and error or AC method. But you know what? It doesn't look promising. So you might want to, if you can try all those other, but when you run out of options and can't get it to factor, what can you do? Quadratic formula, you got it. What do you need to know to work the quadratic formula? Okay, here's what it is. In this problem, m is your variable, so m is equal to minus b plus or minus the square root of b squared minus 4ac. Okay, almost has AC method in it, doesn't it? Not quite. Over 2a. Well, what in the world is a, b, and c? 38. B is 60. C is 21. Okay, so let's go for it. Minus, and what's your B? 60. Plus or minus the square root of. Now, do you want me to write all this out, or can we do it in our heads? What's 60 squared? Anyone know? 3,600. 3,600. This one I can't do in my head, so I'm going to write it out. 4 times A, which is 38, times C, which is 21. All over 2 times A, which is 2 times 38 would be like 76. Is that right? Okay. So this will be minus 60 plus or minus the square root of, I would pull out a calculator if I were you. You can use calculators on the test, remember. I would plug this in just as it reads. Now, depending on what kind of calculator you have, if it's simple ones, 3,600 minus 4 times 38 times 21 equal. What do you get that to be? Say that one more time.
25,536.
Now, I don't quite see how you got that. Okay.
3,600
Minus 4 times 38 times 21. Now, maybe your calculator doesn't do rule of order of operations. It may not. It sounds like it doesn't. Okay. So what I would...
Now I got 2 million.
No, okay, start over, okay. Start with this, 4 times 38 times 21. It depends on your calculator. The little cheap ones sometimes don't do the rule of order of operation first. What you get, 4 times 38 times 21. Okay, subtract that from 3,600. You might want to do that in your head or whatever. It's definitely not this number, okay? Say again? 408. Okay, let me See if I can do it. 408 over 76. Okay. Now, what do we concern ourselves with things under radicals? Does it contain a perfect square? Can you think of any perfect squares that might go into 408? Four will go into it. Okay, let's do that. So this will be minus 60 plus or minus the square root of 4 times the square root of 4 going to 408. How many times? 102. Okay, all over 76. Well, what's the square root of 4? So that'll be minus 60 plus or minus 2 times the square root of 102 over 76. Now, let's time out a little on 102. I know 2 will go into that 51 times, but 51 may be a prime number. So I don't think there's any other perfect squares in there, okay? So I think we've gotten all the perfect squares out, but now we can factor out a 2 out of everything. That'll be 2 times a negative 30 plus or minus the square root of 102 over, and down here we'll factor out a 2, and your denominator is left with a good old 38. That's where it came from, remember? So maybe I shouldn't have done that. Factor out the 2's, and that gives you minus 30 plus or minus the square root of 102 over 38. That's as simple, I think, as we can make it. And let's see if one of these answers will work. Looks like maybe number Bravo, right? B. 78 comes out to be B. Good for them. Make sense? Okay.
So anytime before Thursday or up until Thursday.
What's that again?
Come take it before Thursday.
Yeah, before Thursday. I'd say before Thursday at 6 o'clock in the evening, okay? All right, glad to. Okay, now what I'm probably going to do is go next door where they're taking the test and set up camp over there. That's what I'm going to do the rest of the week. Wherever people are taking tests, I'll be in that room, somewhere between here and there. Okay, since they've already started there, I'll get out. So I'm going to turn off Screencast-O-Matic. It'll be up there